Hi Bobcats! This video is going to wrap up Chapter 1 with a couple more ideas from physics that we borrow all the time in chemistry. Our objectives for this section are to describe thermal energy in terms of particle motion. We need to be able to convert between Celsius and Kelvin temperatures. And we also want to be able to convert energies between units of calories and joules. If we could see the motion of the individual atoms and molecules that make up a substance, we would notice a very strong pattern in the motion as temperature changes. The hotter something is, the faster the particles move, and the colder something is, the slower the particles move. Thermal energy is due to that movement of particles. If the particles are moving faster, the substance has more thermal energy and it has a higher temperature. The terms energy, heat, and temperature sometimes are used somewhat interchangeably, but formally speaking, heat is actually a transfer of energy. It's the transfer of energy from a hot object to a cold object. So now that we have formally defined that, I think you'll find that as we go through this course, we probably will use heat and energy fairly interchangeably, even though formally they're slightly different. And then temperature is just how we measure how hot or how cold an object is with a thermometer. This diagram compares the Fahrenheit, Celsius, and Kelvin temperature scales. Fahrenheit are the units given. If you turn on the local TV weather forecast, they'll talk about the temperature in Fahrenheit. Celsius is the temperature scale that's used most commonly in lab. So if you walk into one of the chemistry labs on our campus and you pick up a thermometer, you'll see that it's reading in degrees Celsius. Some theoretical calculations, though, require that the temperature be entered into the equation in a unit that's called Kelvin. The Kelvin scale is very similar to the Celsius scale, but their 0 point is set at a different place. So for instance, on the Kelvin scale, or on the Celsius scale, 0 degrees Celsius is the freezing point of water. So right here at 0 Celsius, we're looking at the freezing point of water. In the Kelvin scale, that's actually 273 degrees. Now, the size of a degree Celsius and a degree Kelvin is exactly the same. So if we were to drop 1 degree down and go from 0 degrees Celsius to -1 degree Celsius, we would drop by 1 on the Kelvin scale as well. 273 would become 272. Well, the 0 point of the Kelvin scale is set all the way down at this theoretical limit known as absolute zero. Absolute zero is the temperature at which all molecular motion has slowed down so much that it has ceased. So when all molecular motion ceases, the temperature is absolute zero. And that is where the 0 point of the Kelvin scale is defined. So 0 on the Kelvin scale is this temperature called absolute zero, and that corresponds to a -273 Celsius. So this equation down at the bottom is kind of hard to see. I'm going to rewrite it up here. The temperature in the Kelvin scale is equal to whatever we have on the degrees in degrees Celsius plus 273. If I give you a temperature in Kelvin and want to know what that is in Celsius, you could rearrange this equation and you would get a temperature in degrees Celsius is the Kelvin temperature minus 273. Also notice just one little fine point about how we write the different temperature scales. Celsius, when we use that as a unit, we always use the little degree sign with it, but on the Kelvin scale we don't. We just write K for Kelvin. If we're doing some sort of measurement of energy or a calculation on energy, the units that we most commonly use are calories and joules. Calories are from our non-metric system. Joules is the unit from the metric system. The equivalence between these two is that 1 calorie is equal to 4.184 joules. There's also kind of an interesting one here on this slide. If I can find my pen, there it is, got it. 1,000 calories, which could also be considered a kilocalorie. Whoa, I don't know what I just did there. 1,000 calories or 1 kilocalorie is equivalent to 1 capital calorie. That's what's used for food. If your food label is written correctly and it says that this snack has 40 calories, it should be with a capital C. 1 food calorie is equivalent to 1,000 scientific calories. If we need to do a conversion between calories and kilojoules, we would start by writing the number we were given, which is the 325, and its unit, which is calories. We're going to place that over 1. Now we're going to multiply by a conversion factor. On the previous slide, we saw the relationship between calories and joules, and that was that 1 calorie is equal to 4.184 joules. I put 1 calorie in the bottom so that I have calories in the top and the bottom and they cancel out. And then joules, the other half goes up top. And if I take that and run that through my calculator, let's see, I have 325 times 4.184, and that's going to give me 1,359.8 joules. If I wanted to report that in kilojoules, like we are asked to, there are 1,000 kilojoules in every one, there are 1,000 joules for every 1 kilojoule. So I need to divide this number by 1,000. Another way I could do that is move the decimal 3 times. So that could also be written as 1.3598 kilojoules. Circling back to our objectives, in this section we learned how to convert temperatures between Celsius and Kelvin. Temperature in Kelvin is equal to our temperature in degrees C plus 273. And then we learned how to convert between calories and joules, where we found that 1 calorie is equal to 4.184 joules. And we also saw that 1,000 scientific calories are equal to 1 food calorie, and the food calorie will be written with a capital C.